Hi everyone, welcome back. In this video, we'll see the introduction to CPU scheduling. Guys, CPU scheduling means which will schedule various process. How it is going to schedule? By making use of short-term schedule. Okay, means short-term scheduler will select one of the best process out of n process which are available in the ready state and send that best process to running state, right? So here selecting the best process can be done based on many factors, we can say. So in order to achieve various kind of factors, we'll go with various kind of CPU scheduling algorithms. I mean, if I want to complete certain kind of a process based on first come first serve, we'll move with one kind of scheduling algorithm. If you want to complete a particular problem with respect to optical time, we'll move with one particular problem. Like that, for various kind of requirement, various kind of algorithms are existed. We'll go with that depending upon the user need, right? So in short, CPU scheduling is meant for selecting the best process and will make it into the running state. The major goal of the CPU scheduling is to maximize the CPU utilization, right? So we have to make the CPU as much as busy as possible. Based on that, we have to follow certain kind of algorithms and we have to maximize the throughput of the CPU. Throughput means generally the number of processes completed per unit of time. Number of processes completed per unit of time, we can call it as throughput. We have to make this achieving. And third one is we have to minimize the waiting time and we have to minimize the turnaround time. These are the two factors that we have to make it minimum, right? So right now you don't know the meanings of waiting time and turnaround time. In further videos you can understood it clearly, right? So you have to understood the main goal of CPU scheduling is to make the CPU as much as busy and the number of process completed per unit of time should be more and you have to minimize the waiting time of the processes, right? And where can we apply these scheduling algorithms? Guys, if you remember the life cycle of a process, we have a ready state, then we'll have a running state. Here we have n process will be existed and one process will run in the running state, right? So if you want to select the best process among all the readily available processes, what you have to do? You have to apply CPU scheduling, right? So where we are going to apply the CPU scheduling algorithms? So we are going to apply at the ready state, right? So we'll apply at the ready state. But on what factors we are going to apply this CPU scheduling? Try to observe when a particular process completed its running state. Then what you have to do? You have to load one more process from ready state to running state. Am I right or not? Yes. Which means that when a transition happens from running to completion state, do we need to apply CPU scheduling? Yes, we have to apply. Or else, when a particular process is moved from running state to wait or blocked state, again the CPU is going to be idle. Then to make the CPU busy, I have to load one more process from ready state to running state. Yes, which means that when a transition is happening from running state to wait state, means if an IO request happen or any kind of system calls might happen, you have to work with CPU scheduling, right? But the first one, it is something like completion of work. And there might be some kind of situations where it will move from running to ready state. Is this possible? Yes. When an like interrupt might happen. Interrupt means something like preemptive algorithm may work, which means if time bound happens or some kind of preemptive process may come, at that situation you have to apply again CPU scheduling algorithm, right? Similarly, if a particular process moves from waiting state to ready state, do we need to apply again CPU scheduling algorithm? Yes, it is because the process which is moving from waiting state to ready state might have the highest priority. It has to check, right? For that reason, again, CPU scheduling algorithm is going to work at the ready state, right? And there might be a situation that might be something like new to ready state. There might be a particular process which is loaded from second memory to main memory, and this process, the newly arrived process, might have higher priority. So to identify whether it is have highest priority or not, again you have to run the CPU scheduling algorithm, right? So these are the 5 situations, or these are the 5 factors where you have to apply CPU scheduling algorithm. Okay guys, in the next video we'll see what are the various kind of CPU scheduling algorithms are there with some hierarchical manner. Hope you understood this introduction part.